Overlay analysis is different than joins in some important ways. One way is that with overlay analysis, we actually cut new polygons. We end up having a lot more polygons than we may have started with in either of the input layers here. That's one way. The other way is that all of the attributes from both of these layers are combined into these new polygons that we're creating. So everything gets assigned just the type of attributes that they're expected to. So in this example here, we can see that the attributes associated with this brown outline here are coming from this brown competence layer, and that includes what the competence is, high, medium, or low, and what type of rock it is, and the unit name and other information. The rectangle outline in blue here shows what's coming from the slope class. That's the FID of the slope class, and also the class of the slope, some indication of how steep it is. So both of those are coming from these two different layers, but they're being combined into this new polygon that's shown outlined here. And in this case, this new polygon may or may not be cut by both these layers. Here is typically coming from the competence layer, and those are the values that are going into there. What we really do with this is we get away from those one-to-many relationships that often occur with spatial joins that we really don't have to deal with when we use these classic overlays such as union and intersect. So let's take a look at what the difference is. With intersect, we're taking two different layers here, our input 1 and our input 2, and we're outputting something where it's just over the area that they share. So we can see that we can't go beyond this line here because that's kind of a smaller area than the area that we're seeing here. At first sight, this looks like a clip, but if we were just clipping this, we wouldn't have gotten this inside circle here, which is coming from the second layer, and we would only have 4 polygons as opposed to 8 polygons in this output layer here. The other related command is union, and that basically combines the two, but it also cuts all these polygons and makes new polygons. So before we had a polygon over here. Now after we do the union, we have one polygon here, we have another polygon here, and we have a third polygon here. We've gone from having one polygon here to 3 polygons over here. So let's look at some examples of this. In this sort of union, what we're doing is we're combining the data and the extent, as we typically do, and then the tables can be queried for combinations of values. So in this example here, we might be saying that all areas that are composed of limestone, which we're getting from the rock type, which was from the competence layer, and have a low slope, might be areas where we have sinkholes or areas where the limestone is dissolved in the ground. Rockfalls might be areas where we have high slopes and high competence. And now we'll be able to get all of this from this union layer that we have here. And then the landslides might be areas of low competence where the rocks are kind of brittly and crumbly, and they also have high slopes associated with them. All of that would be stored in the new attribute table after we've done the intersect or the union command on the competence layer and the slope layer. And here would be another example here where we have elevation and limestone, and we know the areas where there are dense conifers. And all 3 values might have to be true as far as what the elevation range is, whether or not there's limestone there, and whether or not there's dense conifer there, in order for the snail habitat to be delineated here. So we need information from all 3 of these layers, and this is where it's appropriate to do a union command so that we can get all of that in the same attribute table with new polygons, because we might have some of these smaller polygons that don't match the dense conifer. They might be the dense conifer cut by the elevation or cut by the extent of the limestone. Another example with intersection and geometry associated with this union command is that an intersection can be applied to all geometry types. So with the union command, we can only perform unions with 2 polygons. So if we have 2 polygon layers, we can perform the union command, but the intersect command we can use with points, lines, or polygons. And in that case, with intersect, we can say whether lines occur within polygons or points occur within polygons. And if the points do occur within these polygons, then they inherit all of the information associated with that polygon layer within which they reside. So when we're doing intersect, we can kind of have different types. We can either have points, lines, or polygons. We can have the points and lines as input, and we can have points, lines, or polygons as output. So let's take a look at some examples. Here we have 2 polygons, and if we do an intersect command, we would end up with one new polygon that looks like this. It just shows our area of overlap, and we could put out a polygon if we wanted to. We could put out a line feature if we wanted to, or we could just put out the 2 nodes, the 2 points here, where the that were used to define these 2 lines for this line feature here. If we start with 2 line features, we can look at where those 2 line features overlapped or intersect, and that would be this location here. So we can put out a line feature by intersecting two input line features, or once again, we could just put out their endpoints, as in this example here. And this looks similar because I've colored this in green, but think of this as just an outline of a line, of a circular line, and we're going to intersect that with the roads network here. That can put out a line feature, such as these lines here, or it could just put out the points along the circle where those roads would be cut by the circle. So intersecting can work with point, line, and polygon features, and you just have to be aware of what you're trying to get out of those different intersections as you're doing your analysis. So one thing that's important to compare is how these overlay analyses compare with extraction analyses. And with overlay analyses, they're different than the extraction analyses because they combine all of the features from both layers, and this is not true of the extraction. With the extraction, we're basically just using this edge here as a cookie cutter. We're disregarding this inside polygon, and we're just cookie cutting using this outside extent of this polygon in order to cut a piece out of this. And so we can see that we would not have these additional polygons here in this output, and we would not have the attributes associated with this second input saved in the output layer here. So if we want to save all of the attributes and we want to save all of the polygons that we could possibly get by cutting one layer with another, we want to use intersect. If we just want to cut something to a boundary, then we can use the clip command.